First of all, of course, they ask me to find the jet parameters. What are the parameters? So see, look at the shape of the network, how the network will appears to be the network will be seen to be like in the form of a T shape, isn't it? For the T shape, for the T network, which parameters we used to find generally? Jet parameters. So try to apply in that manner. Right. Now see what we can do here. Right. And this current is I1. This current is I2. Now this current is what? I1 plus I2. So I can apply KVL in this loop, and KVL in this loop I can apply. Then tell me the KVL in the first loops now here. What will get now here? KVL in the first loop here. Yes, V1, which is equal to what now here? 2I1 plus what? 2 into I1 plus I2. So from this, what I can say, V1 is equal to what now here? 4I1 plus what? 2I2. 4I1 plus 2I2. This is the standard network for the net equation for the jet parameter equations or not. From this we can write on jet parameters. Tell me now Z11, which is equal to 4. Next Z12, which is equal to how much? 2 now. Next T parameters for the second network, second port network. Jet KVL we need to find now here. KVL, apply the KVL here. V2, which is equal to what now here? 3I1 plus 2I2 plus 2 into I1 plus I2 now. So from this V2, which is equal to 5I1 plus 5 plus 4I2, isn't it? So this is also standard equation. From this we can write the remaining jet parameters we can write now. So you see Z21 is how much it is saying? 5, and Z22 is how much it is? 4 now. So finally jet parameters of this network, which is given as what I can say here, 4, 2, 5, 4. The other jet matrix I can say. You can see this network now. From this, tell me now for this parameters. Can I say the network is symmetrical? And what the condition for symmetry in case of a jet parameters? Z11, which is equal to Z22. Then we can say the network is symmetrical. And reciprocal, isn't a reciprocal or not? So here reciprocal condition is Z12 equal to Z21. If it is satisfied, it is a reciprocal. Now we'll see this thing here. So Z11 is equal to Z22, symmetrical, isn't it? Z12 is not equal to Z21, so it is not a reciprocal. So this is not satisfying here. So we can say the network is symmetrical. The network is symmetrical, but not reciprocal. But not reciprocal. Right? Next problem. Find Y parameter and T parameter. Y parameters and T parameters. For this network, as we have seen, for the Y parameters means we have remembered the standard network. What the standard network for Y parameters are? Pi shape. So we should visualize the given network is also in the form of a pi shape. is in the form of pi shape or not? Yes. So the y parameter, the condition is what now here? Should be units or ohms or mhos? Mhos. First of all, convert into mhos. So here, what I am assuming this as this network. This is a network now here. So I can assume this as mhos means what? 1 by 2 mho now here. Now here we can have impedance, and this is open circuit. Now impedance is how much here? Infinity. So I can say admittance, I can say as a, sorry, mho, here also. This I can say as a mho, isn't it? Impedance is infinity, so I can say admittance is 0. Impedance is infinity, admittance is 0 now. So like this. Now tell me this thing here, we'll proceed it now. We'll find the parameters, remaining parameters now. So this is the form of a pi shape or not. Directly we can find this y parameters. Y11 is sum of these two, 1 by 2, and y22 is sum of these two. This is 1 by 2. And y12, y21 is minus 1 by 2, minus 1 by 2. Like this. Now see this network. Now we should find the t parameters also, transmission parameters, like this now. And for the transmission parameters, the standard shape of a network must be what now here? Inverter L. Is it inverter L form or not? We should make it as inverter L shape. There is no connection. I can call here this impedance. How much the impedance? I can treat it as an infinite ohms. So now this is what it is, a ZA, isn't it? And this is what? ZB now, both are in ohms only. Now as we have seen the T matrix, as you remember the formula, that is what it is, a 1 plus ZA by ZB, and after that 1 by, remove 1 by 1, ZA, 1 by ZB, and this is 1. So tell me the T shape now here. T parameters now, tell me. 1 plus ZA is 2, ZB is infinity, means 1 by ZB is equal to 0, I can say. So this is 0, 1 by ZB. ZA is 2, 1 by ZB, 0, 1, isn't it? So this is 1 to 0, 1. These are the T parameters, right? Next, for this, find the Z parameters and T parameters here. The same thing here. First of all, we should visualize this, that Z parameters means we should treat this as a T network. T network means here we have only one element here. I can assume here we have one element having the 0 ohms. This I can assume this has 0 ohms, isn't it? So can I write the Z matrix from this network? Tell me Z gains, sum of these two. So that is 2. This is 2, 2, 2 now here. We have Z parameters. This is for Z parameters. Next, T parameters. T parameter, the standard network is what? inverted L shape now here? Is it inverted L shape or not? So I can call this as a ZA, this as a ZB now. Now tell me the T network, T parameters is what? 1 plus ZA by ZB, that is 0. Next ZA, this is 0, 1 by ZB, next 1, isn't it? Like this we can find this parameters. So try to understand this thing here. In next we'll do, firstly we can do here this parameters. Fatafat, by looking at the problem itself we can write. Next one. Tell me here, this is find the y parameters in this case. Now here they ask you to find the y parameters. Whatever we can write firstly. Yeah, we'll do the y parameter firstly. Whatever we can write, isn't it? Tell me what we can do. Y parameters. This is somehow these two directly 25. 25, isn't it? No. See the units are forms given now. So convert it to Morse. It is what? 1 by 20 plus 1 by 5. Next, this is minus 1 by 20, minus 1 by 20. Next, 1 by 20 plus 1 by 10. So we need to convert them in what form it is a Morse first of all. And then we need to do simplify it like this. Yes. Fine. Ohms given now, so we have to convert it to Morse form. And then simply adding. And do simplify, get this answer. Next, Z parameters. For this Z parameters, फटाफट बोलिए. T shape only given ना. So here the Z parameters means we should take care of this units must be ohms. Ohms only given. So tell me 3, 2, 2, 5. Over. Next, Y matrix, Y parameters. Y parameters we can do. Now, what we can do, you tell me here, how we can approach now, tell me, for this Y parameters. So, for Y parameter, generally we should approach for this KCL. If we write the KCL, that is nodal equation, directly we can get Y parameter. If possible, do, otherwise we will modify this thing. We can see here this one. This is V1. What I can do here, this thing, we can apply the KCL here at this node. Tell me KCL at this node, what I can say here. So this is I1 equal to what here? V1 by 2. So leaving current now. So that is how much it is, 0.2 V2. Directly we get the Y parameters, isn't it? Standard equation now. Now here there is no alternative to apply the nodal equations. So let us do mesh equations. Let us apply the KCL here. So V2 I can write it as 4 into I2 plus 10 V1. So I2 I can arrange this equation. I2 which is equal to minus 10 by 4 into V1 plus 1 by 4 into V2. Do check it. Now this standard form of a y parameter equations, isn't it? See this thing here, you can write the y matrix from here. Y matrix I can decide it now here. 1 by 2, this is 0.2 minus 5 by 2, and this is 1 by 4 now, like this. And you can see is the network is symmetrical, and what the condition was symmetrical in case of a y matrix, y parameters, y11 must be same as a y22 if it is symmetrical, and then reciprocal y12 is equal to y21, that is a reciprocal. Is a symmetrical, it is not a symmetrical and not a reciprocal also.